Assalamu alaikum everyone. I am Aliya Jannat. Today the topic of my presentation is samarium, a chemical element. First of all, we will talk about the definition of samarium. Samarium is a silvery white metal which belongs to lanthanide group of periodic table. It slowly oxidizes in air. Now, let's see some general details of samarium. The symbol of samarium is Sm, its atomic number is 62 and atomic mass is 150.36. Samarium is a rare earth element which belongs to period 6 and F block elements. The crystal structure of samarium shows rhombohedral geometry. Samarium is weakly basic in nature. If we look behind at the discovery of samarium, we will come to know that it was discovered by Paul-Émile Lecoq in 1879 in Paris. Samarium is not a pure metal. It was extracted from a mineral samarskite. Samarium was named on the name of the mineral samarskite. Its former name was Samaria and former symbol used for it was Sa until 1920s. As you can see in the picture, samarium is a bright silvery white metal. Samarium is the hardest alkaline earth metal on the earth crust. But at the same time, it is very brittle, which means that it can be broken down very easily. Samarium is a big atom. Its atomic number is 62 and atomic mass is 150.36. One atom of samarium contains 62 electrons, which revolves around its nucleus. There are 62 protons and 88 neutrons in the nucleus of its atom. If we talk about the occurrence of samarium, we will come to know that it is the 40th most abundant element on the earth crust and found up to 2.8% in several minerals. Most common sources of samarium are monazite, bastonosite, samarskite, cerite, and orthite. Because samarium is not found in pure form, these minerals are mostly found in the countries like China, US, Brazil, India, and Australia. Here are some atomic properties of samarium. Its atomic radius is 180 picometer, but in covalent compounds, its covalent radius is 190 picometer to 206 picometer. You can see the electronic configuration of samarium on your screen. Samarium is one of the few lanthanide elements which can attain +2 oxidation state, but it usually assumes +3 oxidation state. According to the Pauli's scale, electronegativity of samarium is 1.1 SEM. To remove an electron from the outermost shell of the samarium, we need 554.5 kilojoule per mole energy. It means its ionization energy is quite high. Now, we will see some physical properties of samarium. Samarium exists in solid state at standard temperature and pressure. Samarium has high melting and boiling points. As you can see on the screen, its melting point is 1345 Kelvin and boiling point is 2173 Kelvin. Samarium is the most third volatile lanthanide element on the earth crust. Its density is 7.52 gram per cubic centimeter, which is quite similar to zinc. Samarium shows paramagnetic behavior at the room temperature, but at the temperature 8 Kelvin or below 8 Kelvin, samarium behaves as superconductor. The color of samarium is silvery white. Next point is chemical properties. Samarium is stable at room temperature and ignites itself at 150 degrees Celsius or the temperature above. It is electropositive in nature. Samarium readily dissolves in dilute acids, but it develops a greenish yellow layer on its surface when we store it under the mineral oil. Sm2 plus ion is a powerful reducing agent and gives red blood color in aqueous solution. When we look at this table, we will come to know that there are 7 isotopes of samarium, out of which 4 are stable isotopes and 3 are radioactive isotopes. The atomic masses of these isotopes ranges from 128 to 165 grams per mole. The half-lives of radioactive isotopes are also given in the table. Samarium can react with many molecules. Here are a few examples of bonding of samarium. Reaction of samarium with water. Samarium is quite electropositive in nature and reacts slowly with cold water but quite quickly with hot water. When samarium reacts with water, it forms samarium hydroxides, as you can see in the equation. Reaction of samarium with halides. When samarium metal reacts with halogens, it forms trihalides. Moving to the next slide. Reaction of samarium with oxygen. Samarium metal tarnishes slowly in air and bonds readily to form samarium-3 oxide. The most stable samarium oxide ion is samarium-3 oxide Sm2O3, which is not achieved by direct heating but with the induction heating. Samarium is one of the few lanthanide elements that can form a monooxide, SMO. Samarium monoxide has a cubic rock-like structure which shows golden yellow luster. Reaction of samarium with acids. Samarium reacts rapidly with dilute acids except hydrofluoric acid, in which it is stable because of the formation of protective layer on its surface. But as you can see in the equation, when samarium reacts with hydrosulfuric acid, it forms samarium-3 plus ion, sulfate ions, and liberate hydrogen gas. Samarium can also form organic and inorganic compounds. Alkyls and aryls of samarium can be obtained by metathesis reaction of samarium with ether. We can also prepare inorganic compound from samarium by melting a graphite metal mixture in an inert atmosphere, which gives samarium carbides. Numerous crystalline binary compounds can also be prepared by reacting any element of group 14, 15, or 16 with the samarium metal. As we have discussed earlier, samarium is not a pure metal. It is extracted from other elements. So there are 3 methods of samarium extraction. The first one is ion exchange method. The second one is solvent extraction method. And the third one is electrochemical deposition. We can obtain samarium by the reduction of its oxides by lanthanum metals. If we talk about the applications of the samarium, it have very vast applications. Samarium is used as a catalyst for dehydrogenating agents. Samarium 153 isotope is used to treat cancer due to its radioactive nature. It also acts as an absorber in nuclear reactors. Samarium is a strong magnetic metal. That's why it is used in many electrical devices. For example, guitars, headphones, mobiles, small motors, etc. It is also used in carbon arc lamping. Samarium is mainly used in the doping of calcium chloride crystals, which are used in optical lasers. The biological role of samarium is not very vast. It stimulates our metabolism. The total amount of samarium salts in human body is about 50 micrograms. Insoluble salts of samarium are non-toxic, but soluble salts of samarium are slightly toxic. Samarium is not a part of the human diet because plants do not absorb samarium. So this was my presentation. I hope you all like this. If you have any question about any point, please let me know. Thank you.